Good morning, Honors Pre-Calc students. This is Mr. Mitchell, and we're going to look at Section 1, rectangular coordinates, two-dimensional coordinates. So we're going to start with some things that you probably have seen before. I'm not going to assume that you have, but probably. So got a Pythagorean theorem formula. There's your triangle, right triangle. A squared plus b squared equals c squared. We have our distance formula, which derives from the Pythagorean theorem. So you can see it's the square root of x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of that. And then we have our midpoint formula, which is you add the two x coordinates and divide them by 2. You add the two y coordinates and divide by 2, and then that's the midpoint formula. So those are the formulas that we really need to use for this section. So sorry about that. I forgot to erase. So we're going to start with the distance formula. So we have 2 points, and we need to find the distance between them. Okay? So bear with me as I work through writing on a new device that I have. So we're trying to find the distance. We're going to take the square root of. We have our x coordinate minus our other x coordinate, and then we're going to square that. And we're going to add our y coordinate minus our other y coordinate, and then we square that. Okay, so let's go through simplify. It's -5, and then we're going to square it. It's going to be -3 squared. We've got our square root, so that's going to be 25. Square a negative makes a positive. Square another negative makes a positive. Square root of 34. Does that simplify? Any perfect squares go into 34? 2 times 17, these are perfect squares. Notice our answer says give your answer as a square root, not a rounded decimal. So there it is. Square root of 34. Okay? Alright. I'm going to pause, or you should pause, and give it a shot. Letter B. Alright, so hopefully you've had time to give it a shot. Let's find our distance between these 2 points. So we're going to go -5 minus 9, and then we'll square that. We'll go -3 minus 3, and we'll square that. So -5 minus -9 is -14, and we'll square it. And -3 minus 3 is -6, and we're going to square that. So what's 14 squared? 196. 6 squared is 36. So you add those together. What's that? 232. So now I have to see if any perfect squares go into it. I believe you can divide it by 4. So it's 4 times, what is it, 58, I think. Let me double check. Yeah. So, and then 58 doesn't simplify any further, so that's done. So it's going to be 2 square root of 58. There you go. That's the distance. Notice we're not rounding. Okay. Midpoint formula. The midpoint formula, we're finding the distance between the 2 points, or not the distance, but the actual point of where we want to be between those 2 points. So the x coordinate, we're going to take the x values, we're going to add them together, we're going divide by 2. Now we're going to take the y coordinates, add them together, divide by 2. Notice it is a coordinate. So what's that going to be? 2, comma 0. Okay. So I will pause for a couple seconds. You should pause the video and you could try part B. So we got negative 2 plus, plus 3 divided by 2. And then we have 1 plus 4 divided by 2. So what's that? 1/2. Can't have fractions or decimals. I would leave it as a fraction, comma 5/2. So there's your point, your midpoint. Okay. All right. So now we're gonna try to put a little bit of the stuff we learned to practice. We want to verify that these 3 points make a right triangle. So we've got to do that by finding the distance between all 3 points. So that's 3 distance formulas that we need to calculate. Three distance formulas to calculate. So we'll start with the first 2 points. So we're going to go 2 minus 4. We'll square that. Can't see the points now. Like I said, bear with me on this. New technology. So it's 2 minus 4, and then it's 1 minus 0. We're going to square that. For the sake of space, I'm going to do a little bit of mental math here and try to get a final answer. So this part is negative 2 squared, which is 4. That's 4 after you square it. And then this is 1 squared, which is 1. This is the square root of 5. So I'm going to, I forgot to do this at the beginning. I'm going to label my points A, B, and C. So this is A, B. So now we got to do, might as well go AC. Doesn't matter which order you do them in. So we're going to go 2 minus 5. Square that. Then we're going to do 1 minus 7. We square that. Again, doing some mental math. This part is negative 3 squared, which is 9. This part is negative 6. You square that, you get 36. And what's that going to be? 45? I'm not going to simplify because I'm going to do something else with it. I need to find the distance between the points, but then I'm going to use Pythagorean theorem. So I'm going to end up squaring that anyway. So I'm just going to leave the square root alone. Just knowing what I need to do with it. I don't need to simplify. So that was AC. Now we need to do BC. So I got 4 minus 5, and I'll square that. And then I'll do 0 minus 7, and I'll square that. So a little bit of mental math. This is going to be negative 1. You square that, you get a 1. This is going to be negative 7. You square that, you get 49. Okay. So we found the distance between all 3 points to each other. So now we need to verify if it's a right triangle by using the Pythagorean theorem. You might say, well, which number goes where? Well, the biggest side's always C. So out of those 3 things, because going into it, you don't know what's the biggest side. But here, BC is the biggest side. So we're going to put square root of 50 here, and we're going to square it. And then we're going to put the square root of 5 here, and we'll square it. And then we'll put the square root of 45 here, and we'll square it. 5 plus 45 equals 50. You're verifying that it is a right triangle. Okay. From geometry, if you recall, if these are not equal, you could still tell it's not a right triangle, but you could tell if it's an acute triangle, which means all the angles are less than 90, or it's an obtuse triangle, which would mean one angle is bigger than 90. If this is larger, that means it's an acute triangle, the 2 sides together. If the other side, the third side by itself, is larger, then it's an obtuse triangle. So that's just a little bit of information. We're not really asked to answer that question, but in case that were to come up, you could at least address it. Okay, so I'll pause for a moment and let you try letter B. You can pause the video as well. Oh, okay, hopefully you've had time to do this. Okay, for the sake of time, if you do 0 minus 4, square that, plus 2 minus 5, square that. That ends up, if you do the calculation, you get 25. Down here, if you do 0 minus 4, square that, plus 2 minus 2, square that, you get, I'm sorry, you don't get, yeah, you get 4. Sorry, up here you don't get 25, you get 5. Take the square root, I shouldn't even have scribbled that out. You could take the square root of 25, you get 5. Here you take the square root of 16, you get 4. And then down here, you're going to take 4 minus 4 squared plus 5 minus 2 squared. You get the square root, you get 9 inside there, square root of 9, and then that's going to be 3. Well, if you know anything, 3, 4, 5 makes a right triangle. So it is a right triangle. Okay? Questions? All right, let's move on.